Okay, calculus. 9.9 is about making connections between a lot of the things we've seen this chapter. It's called representing functions using power series, but we really should start with a reminder of a geometric series from n equals 0 to infinity of a r to the n is equal to the sum, as long as r is between -1 and 1, a over 1 minus r. Now how can we use that? Well, the idea is if f of x equals 1 over 1 minus x, these two forms are very similar. It's just where a is 1 and r is x. That means we should be able to back convert this to a summation where a is 1 and r is x. So it should just become x to the n. And that should converge so long as x is between -1 and 1. That's a fraction raised to the n power. So it's a good estimation for the function 1 over 1 minus x between -1 and 1. Now that's only for an interval around 0. Remember, for intervals, what we learned about Taylor series, if you're centering an interval, say, around -1, you need an x plus 1 for being around -1. This becomes a little more difficult for 1 over 1 minus x, because I really need it to be 1 over something minus x plus 1 in order to make it around -1 here. So if I'm subtracting an extra 1 off, I actually needed this to be 2. Oh, you're like, okay. So is it just done right there? Let's look at the original function formation. A is a variable, right? Could be anything. R is a variable. But this 1 and the minus are always the same. So I need to convert this into something where this is 1. Right now it's a 2. So how do I turn it into something else? I need to divide all of my terms by 2. So this becomes 1/2 over 1 minus x plus 1 over 2. And now it's in the a over 1 minus r form. Interestingly enough, if I convert it to its summation, it now becomes 1/2 times x plus 1 over 2 to the n. This original one converged from -1 to 1. This one now converges from actually -3 to 1. So we actually increased the interval we can converge on, even though it's centered at something slightly different. The point is, we can use functions the way they look in order to turn them into series for approximation. So if we go to page 2, number 1, it says, find a power series for f of x equals 4 over x plus 2, centered at 0. So this is the kind of thing we're going to have to do. Now, I know the constant should always be first in the denominator, so let's start with this. In order to get it to look like a over 1 minus r, I know it's supposed to be a minus sign here. But this is the same as 4 over 2 minus -x. So what does that mean? Nothing yet, because what do I always need here every time in order to make it look a over 1 minus r? This has to be 1. So I'm going to divide everything by 2. It's become 2 over 1 minus -x over 2. Now we're in a over 1 minus r territory. So what is the series for this one? Our a is 2, and our r is -x over 2 to the n. Now there's a few different ways you could write this. You could call this, if you wanted, you could pull the -1 and the 2 out. Call this 2 times -1/2 to the n times x to the n. But all this would really do is change the way you're looking at it. Some people may even prefer to just pull this 2 to the n out. If you do this, you could even arguably go separate the -1 to the n out by itself. So this 2 is going to reduce the number of 2's. So it'll become 1/2 to the n minus 1, because 2 divided by 2 to the n become 1 over 2 to the n minus 1. But any of these are all the same thing. So it's really up to you on how you want to do it. Maybe this one was the easiest to understand what's happening each term. Now on number 2, it says, find a power series for 1 over x centered at 1. Okay, so 1 over x centered at 1. I know I need it to be, there is no constant right now in the denominator, so what I'm going to have to do is +1 minus 1, and then I'm going to rearrange the terms. If I want it centered at 1, I know the x minus 1 needs to go together, which means I can call this 1 over 1 plus x minus 1. This is now centered at 1. What's the problem? This is supposed to be a minus, so this is 1 over 1 minus what is essentially 1 minus x. You can also put in negative x plus 1. Shouldn't be a problem either way. So what is this now? This is this a over 1 minus r form? Yes. My a is 1, and this becomes 1 minus x to the n. So this is an example of what you can do with power series to approximate functions, and we'll have more applications in the next video.